Congratulations, you have now successfully completed the week 1 and week 2 of this course, and I hope that right now you have a pretty good idea about what numerical methods do, and also we have learned a little bit about how to write a program or at least a pseudocode. Now we'll get into a very important part of this course, that is the linear algebra. We'll cover linear algebra in 2 weeks, week 3 and 4, and we have to see these 2 weeks together. In linear algebra, first we'll talk about some theory, and then we'll get into the computational aspects or numerical aspects of linear algebra. Your goal will be to understand the theory, understand each of the techniques, numerical techniques, how they work, and then even if there is in homework or not, for each of this technique, you have to write computer programs or at least pseudocodes. Otherwise, you will not learn numerical linear algebra. Numerical linear algebra is the gateway to any modern numerical software. So you must learn this to the full extent possible in this course. Looking at this entire course material, in first 2 weeks, we have completed the introductory topics and the computer programming part, and now I have linear algebra, then calculus, and then something data driven techniques. So next 2 weeks we will talk about system of linear and nonlinear equations, eigenvalue problems, and even before we start with this system of linear equations, we will take up little bit of basic theory of linear algebra. Some of you are already familiar with this from your mathematics course, but I am not assuming much. I'll start from very basics of linear algebra, give you some time to get into the theory of linear algebra, and then we'll start talking about the numerical methods around linear algebra. So that's all for this lecture. Thank you, and I hope to have a very good upcoming 2 weeks with linear algebra.